Hi, welcome to our webinar on scaling databases for SaaS applications. I'm Özgün, the CTO at Citus Data.
And I'm Lucas, part of the cloud team at SaaS Data.
Lucas and I will be co-presenting this webinar. We have about 40 minutes of slides and we'll take your questions in the last 10 to 20 minutes of this webinar. If you previously read our blog post on scaling multi-tenant databases, this webinar will have about a 40% overlap with the contents in our blog. Let's now start with our presentation outline. We're going to start this webinar by introducing SaaS databases. What is a SaaS database? Why do you need to scale it? And when is the right time to start thinking about scaling your SaaS database? As a quick note, I'll use the terms SaaS database and multi-tenant database interchangeably in this webinar. And after that introduction, I'll talk about 3 design patterns in scaling SaaS databases. I'll then focus on one of those patterns and describe its benefits in the context of scaling. Then Lucas will take these 3 architectural concepts and we'll talk about them as they relate to PostgreSQL features and Citus' scaling properties. With that, let's start by defining a SaaS multi-tenant database. If you're building a B2B application, you probably already have the notion of tenancy built into your data model. Typically, most information relates to tenants, customers, accounts, organizations, and your database tables capture this natural relationship. As an example, you could be building a marketing automation tool for other businesses. In this case, each business that you serve, along with their data, becomes a tenant in your database. And the notion of a multi-tenant database isn't new. It's been around for at least 2 decades. What's new, and primarily in the context of scaling multi-tenant databases, is the cloud. We now have cost-effective SaaS applications. These applications no longer only serve dozens of Fortune 500 companies, but they also empower thousands of other businesses. And these SaaS applications more and more rely on open source, and they need ways to scale to tens of thousands of tenants. Further, SaaS applications can store even more information to help their customers, thanks to sharp drops in hardware prices. This way you can store events or track a field's history as you go along. These reasons combined create a distinct motivation to scale multi-tenant databases. And if you're watching this webinar, you probably already have the notion of a multi-tenant database and you already have a multi-tenant database. An important question is, where in your application and database's lifecycle are you? If you're at a stage where you can throw more hardware at the problem, we recommend that you always do that first. Scale up your hardware. Start with that. We also recommend spending time in tuning your database's config settings and optimizing your queries. Those are always easier. In other words, if you don't need to scale out, don't scale out. With that said, if your SaaS application is growing, there will be a point where you're going to start running into performance issues. So when is the right time to start thinking about scaling out? We've seen numerous customers who look to scale out their Postgres databases at Citus. In terms of when to scale, I compiled 3 heuristics that I wanted to share. These aren't hard-written rules. It's best to think of them as general guidelines, just guidelines. The first one is, if your business is growing and you're on the 2nd largest instance type available on your cloud provider, you probably want to start thinking about scaling out. Why the 2nd largest instance type and not the largest one? Because your business will continue to grow on. Being on the 2nd largest instance type will give you breathing room to grow while you start thinking about sharding. A second heuristic that usually applies for OLTP type workloads is auto vacuum. PostgreSQL uses auto vacuum daemons to clean up bloat caused by MVCC. The default vacuum settings are too conservative to begin with. If you haven't tuned your auto vacuum settings, you should first look into making them more aggressive. If you have and you're still experiencing performance issues related to vacuum, then it may be a good time to start thinking about scaling out. A third heuristic relates to how much of your working set your database can serve from memory. Most databases will track how often you hit the cache and when you need to issue disk I/O. For OLTP applications, most of your working set should be served from the cache. Ideally, you'd want to serve 99% of your lookup queries from the cache itself. In PostgreSQL, a good way to calculate your cache hit ratio is by running this query. And if your cache hit ratio for your multi-tenant database is starting to drop below 99%, then it may be a good time to start thinking about scaling out. To recap, you have several heuristics you can keep an eye out for the right time to scale. Now the question is, when you start running into these performance issues, what do you do? What are different design patterns that enable you to scale? At a high level, you have three options. You can create a separate database for each tenant, you can create a separate schema for each tenant, or you can have all tenants share the same tables within a database. Each one of these design options come with different benefits, and I'll look to describe them in the next few slides. Creating a database, a separate database for each tenant, optimizes for isolation of tenants. You may need to use this model in industries such as healthcare or finance that have regulatory requirements. This model also has the benefit that you could give each tenant SQL access to the underlying database and have the tenants run their queries directly against the database. In practice, customers who have isolation of tenants as their primary decision criteria usually lean towards this approach. The second design pattern, the one where you create a separate schema per tenant, sits between options 1 and 3. Compared to the one database per tenant model, this approach does a more efficient job at sharing resources. In this model, you can continue to isolate the tenant's data and queries into a particular database schema. One point to note is that for the isolation of tenants, this model may not satisfy all regulatory criteria related to isolation in the healthcare industry. The third design pattern is the one where all tenants share the same tables in a particular database. In this approach, you simply add a tenant ID column to all your tenants and shard them across your cluster. This approach easily scales to 1,000, 10,000, or 100,000 tenants, since all tenant data lives as rows in regular database tables. This approach also simplifies operational burden. For example, you can add columns to your table schema or create indexes, and the database takes care of all the work across all of your tenants. So how do you pick between these three design patterns? The truth is, each one of these three design options, with enough effort, can address questions around scale, data that varies across tenants, and isolation. The decision depends on the primary dimension you're building and/or optimizing for. A simple rule of thumb is, if you're building for scale, have all the tenants share the same tables. If you're building for isolation, create a separate database for each tenant. And in the following, I'll focus on the scaling dimension, as we found that more users who talked to us had questions in that area. To expand on this further, if you're planning to have 10 or 20 tenants in your B2B application and your database is running into scalability issues, then you can create and maintain a separate database for each tenant. If, however, you plan to have thousands of tenants, then sharding your tables on an account ID column will help you scale in a much better way. In this diagram, for example, we have two tables, accounts and campaigns, and both tables are sharded on the account ID column. Each table keeps data related to over 1,000 accounts as rows within these database tables. And this enables for much better resource pooling and resource sharing within one database. If you create a separate database for each tenant, then you need to allocate resources to that database. Further, databases usually make assumptions about resources available to them. For example, Postgres has shared buffers, makes good use of the operating system cache, comes with connection count settings, and writes logs and data to disk. If you're running 50 of these databases on a few physical machines, then resource pooling becomes tricky, even with today's virtualization tech. If you have a distributed database, on the other hand, that manages all these tenants, then you're using your database for what it's designed to do. You could shard your tables on tenant ID and easily support tens of thousands of tenants. Google's F1 paper is a good example that demonstrates a multi-tenant database that scales this way. The paper talks about technical challenges associated with scaling out the Google AdWords platform to over 1 million tenants. The paper also describes common RDBMS properties F1 leverages for powering the underlying AdWords platform. Some of these benefits are SQL, transaction support, joins so that you can avoid data duplication, and primary and foreign key constraints to ensure that data is there to ensure data integrity. The F1 paper also highlights how best to model data to support many tenants, customers in a distributed database. The data model on the left-hand side follows the relational database model and uses foreign key constraints to ensure data integrity in the database. This strict relational model introduces certain drawbacks in a distributed environment, however. In particular, most transactions and joins you perform on your database and constraints that you'd like to enforce across these tables have a customer-tenant dimension to them. If you shard your tables on their primary key column in this relational model, then distributed transactions, joins, and constraints become very expensive. The diagram on the right-hand side proposes the hierarchical database model. This model is the one used by F1. The key benefit to the hierarchical database model is that it enforces data collocation. In its simplest form, you add a customer ID or tenant ID column to your tables and shard them on customer ID. This ensures that the data from the same customer gets collocated together, and collocation dramatically reduces the cost associated with distributed transactions, joins, and foreign key constraints. Collocation also simplifies costs associated with handling network and machine failures. Now, when we describe using the hierarchical database model for your distributed database, we hear two questions. First, what happens if I have a table that doesn't fit into this model? For example, this could happen if you have a web application that serves different organizations. Each org normally has its own users. However, you may want to simplify the login process for users who log into multiple orgs. For that, you could shard your user's login table on the user ID column and make sure that you don't join it with the other tables in your database. Or you could have small tables that are used in the hierarchy. For them, you could denormalize these into larger tables or create reference tables that are replicated across all the nodes. The second question that we hear relates to how large tenants are and how those large tenants would impact scaling out. If you're looking to migrate your single instance database, then an important question to answer is, what percentage of the total data size does the largest tenant hold? That is, if your existing database serves 100 tenants and the largest tenant holds 10% of the data, then this approach will help you scale by 10x. We find that tenant data in multi-tenant databases usually follows a Zipf distribution. That is, you have popular tenants and then a long tail. When you have 10,000 tenants, this roughly means that your most popular tenant will have about 2% of the data. Of course, these are general guidelines, and the best way to tell is by looking at the data itself. Finally, a second benefit of having all tenants share the same tables is operational simplicity. Another challenge associated with supporting thousands of tenants is schema changes and index creations. As your application grows, you will iterate on your database model and make improvements to it. If you're following an architecture where each tenant lives in a separate database, then you need to implement an infrastructure that ensures that each schema change either succeeds across all tenants or it gets eventually rolled back. For example, what happens when you change the schema for 5,000 of the 10,000 tenants and observe the failure? When you shard your tables for multi-tenancy, then you're having your database do the work for you. The database will either ensure that an alter table goes through across all the shards, or it will roll it back. With that, I am handing it over to Lucas to talk about some of the implementation and particular properties.
Perfect. Thank you so much, Ozgun. That was really Great first part. So I'll talk a little bit about actually scaling out with Citus and how to use Citus in practice for your multi-tenant database. So typically, the situation you're probably in right now is you have, your Postgres client, which, might be your application, might be some analytical queries you're running, that is accessing a Postgres database, typically using the Postgres protocol. When people switch to Citus, the big benefit that they have is that they don't need to change how they're interacting with the database. They can keep using the same Postgres client, keep using the same application drivers to access a distributed database. Behind the scenes, what Citus does is Citus splits up your data into multiple nodes. This can be anything between 2 and 100 nodes where your data resides. In one of these nodes, you see specific shards for parts of the data. In a multi-tenant model, this means typically a single tenant would live on one of these nodes and would have multiple shards belonging to each of those data associated with the tenant. Shards are simple Postgres tables on one of these nodes, so they have the same semantics. You can, run similar queries. You can connect to the worker itself if you want to take a look, if you want to try out an index. It's really the same operational semantics as a Postgres database, but with the benefit of being distributed. Before we go into more details on this, just some quick terminology details. So one important thing in Citus is a distributed table. This is going to be the most important primitive that you work with, which is a table that is distributed across nodes and in the multi-tenant model, splitting it into shards based on a tenant ID. The second thing is a reference table. A reference table is one that gets copied across all the nodes and has the same values on each node, with the idea that you can join it with a distributed table. An example of this could be time zones. Another example might be currencies. Basically anything that doesn't change often and that you need to reference in your queries. A third type is a coordinator table or local table, which are small tables which are independent of a tenant. One example is if you're sharding by company ID, often the users table might be independent of companies if they can log into multiple companies. And so you can have the users table be on the coordinator node, which is the one you connect to, and have everything else be distributed. This really depends on your use case, and we'd be happy to work with you on this, helping you understand where your data fits in this model. One other important concept is the idea of co-located tables. In the current Citus release, or in the next Citus release actually, you can make this explicit. So let's say you have a store that has products, that has purchases. The idea is that all of these tables for a given tenant ID or for a given store ID live on the same node, so that you can run joins against them, so that it's basically isolated to that shard or that node. The one important concept here is that you need to add a tenant ID to each of those tables. So basically here we have the store's ID, we have the product store ID, and we have the purchases store ID. That is necessary so that Citus can route the queries correctly and helps us verify that this is actually a co-located table. So maybe just to repeat this, so co-located table are where all the data for a single tenant lives on the same node. So again, multi-tenant model. You're sharding a table by a tenant ID, and you're also using the same shard count. So this is a detail when you will take a look at the Citus tutorials. You have to specify shard count. In newer versions, you actually don't have to do this anymore. But previously, you always had to make sure that the shard count is the same so that Citus detects this as a co-located table. The other thing is, between co-located tables, joins just work. Basically, all the SQL that you're used to from a single node Postgres still works. Citus will detect this and just push it down to the single node, which can then run it on a Postgres database. One detail, if you have joins between unrelated tables or different tenants, they also work. In Citus, there's different executor types. There is basically the multi-tenant or router executor, which has full SQL support. And then there is the real-time executor, which would be used if you go across nodes, which has a few restrictions. For example, CTEs are not supported. This is, for example, helpful if you're trying to do analytics. The best example would be, count count my users. Give me a count of all the users across all shards. You don't want to specify this by tenant ID, and you don't have to. Citus can plan queries like this for you as well. So one question we hear often is, how much of my application do I actually need to change, right? It's like, you're running on single node Postgres right now, or maybe you might even be running a different database, right? But like, assume you're running on Postgres, how much do I need to change when I move to Citus? And so one kind of heuristic for that is typically it's less than 500 lines of code. So you really don't need to change that much because your ORM will still be working. The queries you've written before in the multi-tenant model will still be working. And there's a few details around ingestion, a few details around if you are running analytical queries across nodes and you have to watch out for. But in general, it's, you don't have much work here. Going into detail on these changes you have to make. So if you're using an ORM like Active Record, the one important thing that you have to do is, if you move to Citus, is that the tenant ID or store ID or whatever it is on your system needs to be in all the select, update, and delete statements. Typically, select is the easiest because you're already querying for data, and you usually can just add the thing you're querying for. Updates and deletes can be a bit more tricky. So update and delete, typically in ORM could be, you load a record, you do record.delete or record.update, and then the ORM identifies the column using a primary key. What you need to teach your ORM is that the ORM needs to support multiple primary keys or composite primary keys, where basically you can reference a record not just by its own ID, but also by its tenant or store ID. This in Active Record, for example, in Rails, there's existing libraries. For other ORMs in Java and Python, there's also libraries. We'd be happy to work with you on this. It's just one thing you need to watch out for. The other thing is that if you are setting up your tables, you need to call a function called master create distributed table, which basically sets up the table to not be a local or coordinator table, but actually be distributed across multiple nodes. And typically in your ORM, you can just call execute and basically call the SQL. So that's not a problem. The other thing is if you do have cross-tenant queries, again, as mentioned before, they are possible, but they have some restrictions on the SQL coverage. So you might run into these restrictions. We'd be happy to work with them on you, and every Citus release has more SQL support. So if there is an issue, please let us know. And the third thing is if as you're migrating, you want to have confidence. And the best way to gain confidence is to both run, of course, your production or staging environment against it, but then also have, as you make changes, have the confidence that this, like your application integrates well. And so the best thing you can do is have both your test suite and your CI environment run against Citus. For your local environment, you can typically just use Docker, and we provide Docker images ready to go, so you can just drop them in. They work similar to like the Postgres Docker image, so it's not much work usually. On a CI environment, it depends on the provider, but we can also provide you with scripts that basically help you test against Citus. Then one more note, when you're migrating to Citus, one thing you will encounter is transactions. So this is again, depending, sometimes you issue your own transactions, sometimes your ORM does it for you. The one thing to keep in mind here is since we are in a distributed database, distributed transactions are possible, but they're expensive. And so you don't want to do distributed transactions, you usually want to do a transaction on a single node. In Citus, this means, or in multi-tenant model of Citus, this means you can basically, if it's on the single node, you just use the typical begin, run some SQL statements, commit. That just works as expected, as long as all the queries are accessing that single node. And this works both for select, update, delete, insert, that's all fine. If you're accessing multiple nodes, there is some functions for that, but again, you ideally can avoid this. It is something that typically in a multi-tenant model is not a problem though. For DDL, so let's say you're adding a column or creating an index, it will just work across shards, so you can actually run transactions and run DDL commands across shards. There are some restrictions right now. Again, rest assured that our goal here is you don't have to make any changes. So if you do run into them, please let us know. And then I'll make a note, maybe some a little bit like on another topic here is, if you have a multi-tenant model, often, and this is like more the old school multi-tenant architecture, for example, the one that Salesforce uses internally or used internally, often you have different data depending on which tenant type it is, right? And so if you are storing that data in the same table, there was an old model where you basically said, I have a column where like V1, V2, V3, and basically depending on tenant type, I store different data in each of these columns. The good thing is with Citus, you actually have the full power of Postgres. So you don't have to resort to these, simplistic approaches basically. You can actually, for example, let's say your data is JSON or your data is, HStore like data. You can just store it in Citus, and Citus will basically allow you to have this data that's dependent on a tenant type without enforcing a schema. So if you want to basically have different types of data per tenant, that's really easy. All right, so kind of zooming out a little bit, going into how you can deploy Citus. So there's basically 3 things you might want to look at. We have the community edition. So one important thing to note is Citus is open source. So if you're ever curious how it works internally or also how we work, just take a look at our GitHub. We have all of our issues open, so like if you are interested in certain features coming in a future release, you can also see that on GitHub. That said, there's the open source works and you can use it. On Citus Cloud and Citus Enterprise, we have some additional functionality that we've seen being useful in enterprise or production environments. On Citus Cloud specifically, Citus Cloud is a managed service that runs on Amazon Web Services. We do everything for you. This is also the team I'm on, so I'm a bit biased. But basically, Citus Cloud is similar to, for single Postgres, you might use something like Heuristic Postgres, for example. And we see a lot of customers that outgrow these systems and they still want to have a managed experience. And so Citus Cloud really is, we do it all for you. We run the servers, we make sure that backups are taken care of, HA is taken care of, so that you can focus on your app and don't have to focus on the database, as much at least. The other option you have is Citus Enterprise. So if for some reason you have restrictions that you can't run in the cloud, we do have an on-premise version, which if you're in financial services or in healthcare, this might be of interest. And then just some brief notes, because we do get questions, so then I switched to Citus. So how do I, over time, actually change my application, scale out? Like, what if I grow 10x? And so I think the big benefit is you can still do the same things you've done before in single node. For example, if you wanted to increase your node size, you could still do that, right? So like, let's say you start out with 10 nodes of 50 gigs of RAM, you can just double the size of those nodes. The benefit being that it's not just one node you're doubling, it's 10 nodes you're doubling. So that's always still an option. But the real benefit of Citus is that you're, instead of scaling a single node and scaling vertically, you're actually scaling horizontally. So you can, for example, let's say you start with 4 nodes, you can just add 5 more nodes for a total of 9 nodes as an online operation. In Citus Cloud, this is really easy. And then when you basically want to go from these 4 nodes to actually distributing your data across all the 9 nodes, we have something called the shard rebalancer, which is available in Citus Cloud and Citus Enterprise, which basically moves the data from your existing nodes to the new node so that it's evenly distributed, and does it so that everything is online still, so you don't have to take any downtime to do this. You can just have it do its work, and in the end basically have a 9-node cluster with all the data being available on it. And I'll make a note here that if you are interested in either seeing this as a demo or just giving it a try yourself, Citus Cloud has one-click scaling. So this is kind of inspired by you don't want to have to think about this. If you need to scale out, you can basically just use a slider. So here you can say, for example, we have 7 terabytes distributed disk space, 28 distributed CPU cores, 430 gigs of RAM, and if we just want to double that, we can either double the node count or change some of the other sliders if we wanted to. So it's geared towards you just making these changes if you need them, whenever you need them. So you don't need to, you don't need to make everything in the beginning. You can start out with a couple of nodes and then scale to 100 nodes whenever you need those 100 nodes. And then one last note on Citus Cloud, if you do want to try it out, we also have a developer plan on it, which is $99 a month. So if you just want to basically see how Citus works from a functionality perspective, that's one way to go. It's not the best way for benchmarking, but if you want to give it a try, it's the price of a cup of coffee a day. So really easy start. And then if you do want to get a better feeling for what's the best fit for me, we do have a good get started page on citusdata.com, where you can either if you want to play around with it locally on your machine, there's an option for that using Docker. If you want to try Citus Cloud, it's on there, and if you want to talk on Citus Enterprise and have more of a conversation with us, we're also always open to that. And with that, thank you so much for your time. I'm switching over now to Q&A. Any questions out there? All right, so we have one question. I'll read it out loud, and then I think this might be one for Osman. How do you handle this from Michael? How do you handle a case where each tenant has a different schema? How do I fit this into a single database? So I think this more refers to the initial part. Yeah, does that make sense?
Yeah, it does. It does. And I think Lucas alluded to this question in his slide in here too. Where we looked partially and then quickly over how Salesforce, one of the architectures in here, Salesforce approaches this, and now we talked about how to migrate that over to the semi-structured data types. One way to do this, and I'll call it the previous channel, like the first version of doing this, is for different tenants that have different data and even different data types, you create 1 to up to 500 columns, where we call like value 1, value 2, value 3, going all the way up to value 500. And there you can put in information that relates and that's specific to that particular tenant or that particular account ID in this case. And usually what you do is you also want to capture some data type information. Like for example, in here, the value 3 could be a double, it could be a time, it could be text. Usually you'd encode this as text of the previous generation and then you'd infer the type itself and you do your indexing appropriately. The way this evolves and the way you do this in PostgreSQL or PostgreSQL JSONB is instead of encoding these additional columns, you can just like put them into JSONB fields where you have nested structures, you can represent arrays, and then use PostgreSQL's JSONB features to address data that varies across tenants.
Makes sense. Does anybody else have questions? We're a bit short on questions right now, so feel free to ask anything that you're curious about, or share your current situation. Like we're also happy to talk about the more specifics, like how Citus can help, or in general how you can think about scaling out.
And is there a way to open it up for questions, or is it mostly going over the?
I think it's mostly going over the questions part.
Okay.
Let me check.
So another question is that just came up, is using Postgres for telemetry data, like user browsing history, a good idea by creating a table in the same database? And should one use foreign key relations?
Yep. You want to answer it?
I want to answer that. I have a clarification note. Maybe we clarified with us too. So certainly you can use PostgreSQL for capturing telemetry data and then user history data. Now, depending on the overall use case, if your primary intent is capturing user telemetry data and your queries are going to go over telemetry data, that may fall outside of the multi-tenant use case. Depends on if there is a higher level in the hierarchy. For example, if you're capturing telemetry data for businesses for, say, different entities there, so it may fit into the multi-tenant use case. If you're primarily looking at it on a user-by-user basis, then it may be better to shard this data on the user ID dimension. Again, it does depend if the use case is multi-tenant or if the use case is capturing telemetry data, real-time analytics. But so you can certainly use PostgreSQL for those type of workloads. And the answer is it's for multi-tenant. Then in this case, yes, surely, depending on how many tenants and customers you have, you'd probably, again, shard all your tables on the tenant ID dimension or the customer ID dimension or the business ID dimension. And then you can create foreign key constraints within your tables too.
Perfect. I think we have one more question. Actually, two more questions. Perfect. One question from Marco. How to set up the system in a situation where we have one customer that accounts for 60% of all information in the system? So I think this is kind of the extreme of the large tenant model, like where we really have one huge customer.
And probably the way to go there will be isolating that tenant into its own hardware box. Then again, I think it does depend on how many tenants you have, like whether you have 10 tenants, because I think with 10 tenants, the scaling aspect isn't as important. If you have hundreds or thousands of tenants, then it becomes more in the domain of the approach that we talked in here. Specifically in this context, one approach could be to isolate that tenant to a particular machine.
Oh yeah, and I think Marco made a clarification. He has 100 tenants right now.
I see.
That makes sense. And I'll also add a note here. There is, like in Citus itself, there is a way to basically say, I want this tenant on a certain box. This is something that we're making nicer to use with an upcoming release. But right now, if you have this issue and you want to use Citus, we have a workaround for it. So do ping us if that, if this is your scenario. We can probably figure it out.
There is another question. Are you planning on providing the shard rebalancer feature in the community edition?
I can, if this helps. So, yes and no. So basically, the shard rebalancer's underlying functionality, some of it exists in a community edition. So if you wanted to build your own system and you don't want to use Citus Cloud or Citus Enterprise, you could basically build your own rebalancer. There's details on, basically what you would need for a production system, which more for business reasons, we basically keep on either Citus Cloud or Citus Enterprise. But if you're interested in, just using it in the open source edition, I think there's a GitHub issue on this. You can search for it. There's a function you can call which does part of it for you, and then you would be able to build parts of it yourself if you want to. But I'll say, we put a lot of effort into that particular feature, so I wouldn't suggest going on your own, but there's ways around it if you really need to. And let me see.
There is another question on, does using Citus PostgreSQL have any advantages on MongoDB and Hadoop? And I think the short answer to that question is it depends on the use case and what you're looking to do. If you're looking to do heavy data warehousing and ETL workloads like Hadoop, people use Hadoop in those ways. Depending on your use case, if you're looking to build a multi-tenant application or if you need a multi-tenant database, then we clearly think that Citus and PostgreSQL have distinct advantages. Some of those advantages are, again, transactions, being able to use transactions, keeping SQL and your ORM tooling, being able to do joins to avoid data duplication so you don't duplicate your data, and then being able to use primary key and then unique key constraints to make sure that the data that you put into this database, the integrity of it stays the same.
Perfect. And we have one more question over Slack. I'll just read it out loud. At what data size do I need to start thinking about sharding? Like, should I start sharding at 10 gigabytes? Should I start sharding at 1 terabyte? Like, what's the good measure in terms of data size? And I guess this is for us then.
And the short answer is that it depends. I would say rough ballpark. Again, there are no rules. These are just guidelines. We see that at around 100, 150 gigs, you probably want to start thinking about sharding. And then, like for the multi-tenant use case, then again, a lot of it depends on your use case. So that's why we have these heuristics. If you are curious, then we'd be happy to chat in the context of your particular use case and your requirements.
And actually, just one more question came in. Again, it was like here. Can I run analytical queries across tenants? And if you want, you can answer it.
Yep. Yes, you can. And I think part of it is in here. Yes, you can. Again, as Lucas noted, there are a few queries that we currently don't support, like such as the CTs that Lucas alluded to. For the most common queries, yes, you surely can.
And I'll maybe make an additional note too that the big benefit of Citus here is that you can actually parallelize the queries. We basically have the relational distributed algebra to figure out where to get the data from in parallel and then summarize the result. So Citus is actually really good at this particular detail. Perfect, and I think that's it with questions. So if you have any further questions for us, feel free to hit us up in Slack or using our website. There's a little chat widget on the website that you can just use to talk to us. We're always happy to just talk data modeling, scaling out. We're a company of engineers, so always happy to go technical. Thank you for attending, and I think that's it.
Yep. Have a great one, and have a good day. Thanks.